Hi, it's Dave T here with the next episode in my off-grid power mini series, and the topic of this video is USB powered devices. Now, whilst this series is generally about powering devices off-grid whilst camping, caravanning or motorhoming, the focus of this video will be about USB powered delivery in general. So the majority of the information in this video should be of use to anyone interested in the power aspect of USB. I'll also cover in brief the differences in USB standards in terms of data transmission speeds, just for reference. So with that said, although it's unlikely that anybody watching will not have used USB, some may or may not be aware that they have. So I'll start with a brief history and explanation of what USB actually is and how it came to be created. Pretty much ever since computers were first created, they have been connected to other devices referred to as peripherals, such as screens, keyboards, storage devices, and of course printers. My first experience with computers was as far back as the late 70s, when early home computers were connected to TV screens using coaxial cables, storage was on tape drives using either audio leads or proprietary cables, and there were numerous different means of connecting printers. By the 90s, the types of devices being connected had grown to include anything from mice to cameras, scanners, game controllers, and an exotic range of ever-changing storage devices. Printers had, to a certain extent, settled onto two main cable standards, Centronics and RS-232, but even they had some oddities. This presented a problem to the growing PC computer business. It was becoming harder and harder to create new peripherals that would be compatible with users' machines without the computer itself having to be opened up and new interface cards be inserted. So in 1995, a group of 7 then major computer companies began the development of a new interface standard, which would ultimately become known as the Universal Serial Bus, or, you guessed it, USB. The primary goal of USB was to be a standard so that computers only needed one type of connection, and all peripheral devices would then be designed to work with that connection standard. It was also to be simple to use, require no configuration by the user, be extendable by allowing devices to be interconnected through hubs, and most importantly, at least for those of you wondering why we're even talking about what sounds like a computer standard, it was designed to carry both data and power. Now, for anyone such as myself heavily involved in the personal computer industry, USB really did simplify and revolutionise the connection of devices to computers. Without it, we would likely not have anything like the variety of devices that we can now connect to our computers. But an unforeseen outcome of its creation was that as well as providing a standard for connecting devices that required data, it also created a standard for anything that needed power. Well, at least anything that required power at 5 volts. As more and more people had USB power output devices such as wall adapters or computers, non-computer related product manufacturers started to realise that they could capitalise on the abundance of standardised power. So roll forward to 2022 and you can get USB fans, torches, heated gloves and a myriad of other products, none of which required the use of data transmission features of USB, which was its original main purpose. Which is why it is of interest to anyone thinking about electrical power off-grid, since so many modern devices use USB as their power source. Whilst the original intention of USB was to produce a standard interface, there have been several versions since the original in 1996. Also, the physical appearance has over the years changed so that there are now several standards within a standard when it comes to the connectors, so it's worth running through these now to identify the key differences. It's also worth pointing out that all of these connectors do actually work together, so they're pretty much interchangeable. There are 4 main versions of USB with 3 additional point releases. USB 4 was only released in 2019, and so at the moment there are far fewer devices around supporting this standard. The main difference between these standards is the maximum speed of data transfer. So for example, copying some photos from a camera card to a computer using USB 3.2, one of the latest standards, could potentially be more than 1,500 times quicker than on an original 1996 USB 1.0 device. Now, you're unlikely to see all of that difference, but it is massively quicker, which has enabled a whole load of other functionality such as video over USB, but that's another story. If we overlay the changes in the power specification, you will notice that not much has changed with regards to power delivery until 2012, when the USB PD or power delivery specification arrived. Up until then, the voltage delivered by USB was 5 volts and the maximum current was 5 amps, so basically 25 watts in total. The physical connectors used by USB devices change more frequently, mainly driven by the need for smaller and then slimmer connectors as mobile phones adopted the standard and got slimmer. The original and most common connector is the one you'll most likely be familiar with, which is the USB-A connector. On devices such as a laptop or computer, the inside of this may be color-coded white or black for USB 1.0 or 2.0, and whilst USB 3 ports are blue or teal shade of blue for 3.1, you may also find yellow, orange or red ports which are designated for higher current charging or powered up when the device is switched off. Connectors on the cables themselves tend not to be color coded. Type B connectors have also been around from the outset but are generally only used for larger devices such as printers. The Mini A and Mini B connectors arrived on the scene in 2000 on smaller devices. They are still in use but have pretty much been superseded by the slimmer micro USB connector which followed in 2007. The USB-C connector was specified in 2014 and is the biggest change in terms of power delivery as it coincided with the USB 3.1 and power delivery specifications which I'll discuss later. USB-C connectors have a number of advantages. Firstly, they are reversible, making them easier to use. And secondly, they are potentially capable of carrying up to a whopping 240 watts. But there are some caveats about that which I'll cover later. With a few exceptions related to high power uses based on the power delivery specification, you can generally consider USB connectors as plug and play. In other words, providing the cables and sockets fit together, then they will work, and you can generally find cables or adapters to go from almost any USB connector type to any other USB type. They are also backwards compatible so that they work with any of the USB standards based on the capabilities of the lowest end of the device connection. Because USB cables can carry power, many phones and tablets started to use USB as standard. I'm sure we have all experienced phone batteries running out at inconvenient times, so to solve this issue, suppliers started to create USB power banks. These are usually lithium-ion rechargeable batteries which have USB connectors built in. These will typically have a standard female USB-A socket, which is the power output into which you can plug any standard USB cable, for example to charge your phone or tablet, and they will very likely also have a female micro USB socket into which a charging cable is connected to recharge the power bank itself. There are literally thousands of different power banks available in a variety of sizes, shapes and designs. As a general rule, the more electrical capacity they have, the larger and heavier they are. One thing to be aware of is that almost all quote their capacity in milliamp hours or occasionally in amp hours. This is the same as leisure batteries and is a pet hate of mine since it only states the true energy if you take the voltage into account. For example, if your maths is good, you may think that this 13,000 milliamp hour power bank has roughly an eighth the capacity of this 100 amp hour leisure battery. But the power bank supplies power at 5 volts, which equates to 65 watts, compared to the leisure battery, which is approximately 12.5 volts, which is 1250 watts, 20 times more. Now, of course, with lead acid batteries, you can only use around half that capacity, but you can hopefully see from this example how just looking at the milliamp rating can be misleading. This is especially true with power banks that support power delivery, such as this one, which can deliver power at different voltages. Now let's talk about providing USB power from a 12-volt source, such as in a car, motorhome or caravan. You will have no doubt seen car cigarette socket USB adapters such as these. They are fairly cheap and generally come in 3 formats. The first is plug-in adapters with a fly lead which has a male USB connector at the end of it, and these will usually be a micro USB, USB-C or a lightning connector plug for iPhones. Now personally, I try to avoid these simply because they tend to be the most bulky and the least versatile. They support just one socket type, and of course the lead length is fixed, and if the lead frays or breaks, then the whole unit is useless. Plug-in sockets with fly leads to a second block or part which has USB sockets built into it are less common and generally more expensive, but can be useful if the power outlet itself is not in a convenient location. Watch out, however, for building up cable length, especially with higher power USB devices. Small plug-in adapters that provide one or more USB sockets, usually USB-A, in the main body of the adapter itself are my personal favourite. They are typically the lowest cost, but generally the smallest, and allow you to connect the lead of your choice, making them the most adaptable. If you're powering standard USB devices which do not support or require power delivery or QuickCharge, then pretty much any 12-volt USB adapter from a reputable supplier should work totally fine. Some will state the maximum power output, and it's generally a good idea to go for those with a higher rating. Watch out for a secure fit, as some of the cheaper ones can pop out of the socket of their own accord, which is annoying if you don't notice. And if you choose one with multiple USB ports, then it's worth checking if the stated rating is for the total or for each port. A quick side note about mains voltage inverters here. It makes no sense at all using an inverter to convert 12 volts up to 240 volts only to then convert it back down to 5 volts for USB. Even for power delivery USB, which can deliver up to 48 volts, there are simpler and more efficient devices to raise the voltage. When looking for 12 volt to USB-C power delivery or QuickCharge adapters, unfortunately the specification and marketing can be very misleading. You need to ensure that the wattage for all the voltage and current that your device requires can be delivered by the adapter. Some will misleadingly state, for example, that they deliver 64 watts. However, on testing it turns out that the device has two sockets which can each deliver 32 watts simultaneously. The other thing to watch out for is that the higher power USB PD adapters can get quite warm, so in this case a larger size is at least an indicator of likely better heat management. I've already mentioned USB PD or power delivery specification, which was announced in July 2012. This specification allows for USB PD capable devices to supply power at higher voltages and currents over PD aware cables. That's right, the cable itself has to be PD aware, and this is not just a case of the correct thickness of cable. A PD aware cable is electronically marked so that it can actually tell the power supply that it is a PD cable and to what current rating. It does this by having a controller chip actually built into one or both connectors on the cable. QuickCharge is a charging standard developed by Qualcomm, which is one of the world's largest producers of chipsets for mobile devices. It works in a similar way to the power delivery standard in that it allows the voltage to be increased for suitable chargers and devices. In fact, QuickCharge 4 is cross-compatible with both USB-C and PD specifications. If you have a QuickCharge device, then you should ensure that the charger or 12-volt adapter you are using supports QuickCharge. USB-C, along with USB 3.1 and the PD specifications, offers a real sea change in terms of both connectivity and power delivery. For example, this laptop is being charged by the docking station and connected to this monitor, keyboard and mouse and local area network, all of this via a single USB-C cable. For those of us using power-hungry devices whilst off-grid, this means that they can be powered by any USB port, which of course are fairly common to find, which sounds easy, right? Well, unfortunately there are some limitations which, whilst not insurmountable, can easily catch you out. To begin with, your device will need to support being charged or powered when running by USB PD. You'll need to check this, as you can't just assume that it will simply because it has a USB-C port. If your device can be powered using USB-C PD, then here's what you need to know. Firstly, if you're plugging a USB adapter into a 12-volt car socket, then it must be capable of delivering the required current. At the top end of its specification, PD can supply 240 watts, which means that your 12-volt socket will need to supply almost 20 amps. PD's standard power range actually just goes up to 100 watts, with around 60 being more common, but bear it in mind. So be sure that the socket is cabled correctly, and I'd recommend that it is protected with an appropriate fuse. Next, the USB adapter must support power delivery. If you remember from my video on electrical theory made easy, power is current, amps, multiplied by voltage. Also, you may recall that the power supply sets the voltage and the device determines the current supplied, up to the maximum of the supply. PD supplies additional power by increasing the voltage, which of course could damage devices not expecting it. To do this safely, it negotiates the power requirement first with the device. So if the USB device doesn't support PD, then there's no negotiation and therefore it will just deliver the standard USB 5 volts at low current. The cable used is important, since the cable drawn by the PD devices can be as high as 5 amps. The cable needs to inform the power supply that it can safely carry the current. That's right, the cable itself is intelligent up to a point. Technically, it is electronically marked with a USB PD controller chip built into one or both ends of the cable. This advises the power supply that it is okay to send the correct voltage and current. So to summarise, to power a PD compatible device successfully, you therefore need a suitable USB power port with sufficient current and PD specification and a suitable cable. You can sometimes suffice with cables or power ports that supply less than the device's stated power requirement. In these cases, the device may not receive any power, or it may charge but only when not in use, or it could throttle itself to consume less power when running. Whilst I have not had experience of this, I have read that some devices adhere to the PD specification via the cable rather than the device itself. In other words, they rely on the supplied cable telling the power port what voltage etc. they require. It is often therefore recommended to use manufacturer supplied USB-C cables. Buying suitable USB-C cables for higher power devices can be quite difficult, as advertisers tend to quote a range of compatible phones and tablets rather than quote the actual specifications. The best option I have found is to search by either the current rating or total wattage required, as well as being PD compatible. Apple products such as the iPhone of course have their own specific style of USB plug, known as the lightning connector. Now I'm not going to cover connections between two Apple devices here, but in terms of charging Apple products, the cable will typically be from a USB-A going to a Lightning-C connector. USB-C to Lightning is also becoming more common, and of course many other variants are possible, but not all that likely. Also, a lot of newer Apple products now use the USB-C, for which the earlier information in this video can be used. A standard Lightning cable carries 5 volts up to a maximum of 2.4 amps. The Apple/Intel Thunderbolt standard is physically the same as USB-C, and whilst there are some data related differences such as connecting 4K monitors, from a power perspective it is almost identical to USB-C with power delivery. As previously mentioned, power delivery enabled devices, you should check the compatibility of cables and power adapters carefully, but other than that the advantages and pitfalls are very much similar. So in conclusion, USB as a method of power delivery is a convenient standard which uses common power adapters and cables. Additional rechargeable power banks are readily available in a variety of sizes and price ranges, and of course it's often possible to blag a charge from a public place such as a cafe. If you have any USB rechargeable devices at all and are going off-grid, then it certainly makes sense to have some USB power banks with you also. As well as providing backup capacity, they can be conveniently recharged whilst driving or anywhere else you can get hold of a USB power supply. For those of us camping off-grid, it therefore makes sense to purchase USB rechargeable devices such as lights, torches, mini fans and anything else you can find, in addition to the more obvious tech gadgets. If you've found some USB powered devices that are useful when camping, then please do let me know in the comments below. I hope you found this video helpful or interested, and if you have, then please do hit that like button. If you're interested in seeing other videos that I make, then please consider subscribing to the channel, but most of all, thanks for watching.